So today we're going to talk about specifically just central angles and the arc measures that are related to them. But we're also going to look at arc length and some properties with chords and arcs as well. All right, so quick review, central angles, we talked about that in the vocabulary. It's an angle whose vertex is the center of the circle. We also talked about minor arcs, major arcs, and semicircles. A minor arc is an arc with a measure less than 180 degrees. Major arcs are arcs with a measure greater than 180 degrees. And semicircles is an arc whose endpoints are the diameter and always is exactly 180. All right, total number of degrees in a circle is always 360 degrees. So of course, when we're doing measures, we can't go over that. Now, the degree measure of a central angle is equal to the degree measure of its intercepted arc. All right, again, so the degree measure of a central angle is always equal to the degree measure of its intercepted arc. So here we have a picture of a central angle, angle ABC. All right, so the measure of the arc, and this is the intercepted arc, all right, is always equal to the angle. So if the angle is labeled as 92 degrees, then this arc measure will be 92 degrees. All right, so down here, so the measure of arc AC is 92 degrees. Now, we talked about it's only 2 letters, so I know I'm going the short way. If I wanted the measure of arc AC, but the long way, the major arc, then I have to have a 3rd letter, so I know that I'm going through that point to get to the other end. All right, if a whole circle is 360, then the measure of that major arc will be 360 minus the 92. All right, which will get me 268. Okay, so down here in the first example, it says find the measure of each angle and the arc measure. Be very careful when you're reading. Make sure, all right, the little m is going to be in front of a arc to show the measure, just like we do in front of an angle. All right, and of course, just refer you back up here, right? So this was the measure of arc AC equals the measure of angle ABC. All right, so if I want the measure of arc CD, first of all, let me come look at my picture. Very important, I see couple diameters. So segment CE is a diameter. So that means from C all the way around to E is going to be 180. Okay. That's also happening on the other side. So all this is 180 from C around to E. The box tells me that this is a right angle. So that's 90 degrees. And we just learned that central angles, which this is, because the vertex is the center, is exactly the same as its intercepted arc. So arc C to D is going to be 90. All right, so we can go ahead and put that in. Now, before I look at the other things, I'm going to come over here. So if that side from C to D is 90, but I know from C all the way around to E is 180, then that means that from D to E is also 90. So this is also a right angle in here. I've got some vertical angles. So I know that C to G also is going to be 90 because I've got all these 90-degree angles. So mathematically, that means if I've got 1, 2, 3 90s, that's 270. All right, and that means from G to E is also going to be 90. So I can just do 90 minus this 28, and that's going to get me G to F. And so that's going to be 262 degrees. So now I've got not only my arc measures, but I've got all these central angle measures as well. All right, so coming back here, so if I want the measure of arc FD, so I'm going to start at F, and I'm going to go to D, and it has 2 letters, so I know I'm going the short way. I'm going to add 28 and 90. That's going to get me 118. C, I want the measure of arc DCF. 3 letters, so D. I'm going to go through C, and then I'm going to end at F. All right, so I've got 90 plus 90 plus 62. 90 plus 90 plus 62. That's the math that I'm doing for that. So that gives me 2, let's see, 18, 24, 242. And then the last one wants the measure of arc GDF. So I'm starting at G. I'm going to go through D and end at F. So I'm going this way, all the way around, the long way. Again, starting at G, through D, ending at F. So the easiest math for me, I can either add up all these pieces, or I can just do 360 minus the one piece not included, which is the 62 piece. So that's going to be 8, 9, 298. Check my math here. Yep, 298. Okay. Number 2, when you look at this picture, you've got to notice we've got some diameters. So that means that this 5x minus 41 and the 7x plus 23, those two together are going to add up to be 180. So that's how you would set your equation up to solve. So 5x minus 41 plus 7x plus 23 equals 180. So we've got 12x minus, let's see here, 18 equals 180. And then I'll add the 18 over. 12x is 198, and then divide by 12. Let's see here. $16.5, and it just wants us to solve for x, so I am done. All right, you'll see some problems, of course, where they give you all the different parts. Okay, so then you would add them all up to be 360, but we just had half, and we got to pay attention to those diameters. Now, what we've been using, and we used it up here, is this arc addition postulate. You remember way back at the beginning, we had a segment addition postulate, and we had an angle addition postulate, which basically said small part plus small part equals the big part. So it works the same in a circle. The measure of an arc formed by 2 adjacent arcs, so these two need to be side by side, is the sum of those 2 arcs. So small arc plus small arc will equal the bigger arc. Okay. All right, so that's some work with central angles. Let's talk about arc length. All right, so yesterday we reviewed circumference, which was essentially the perimeter of a circle, the distance around it. But arc length is then going to be a fraction of that. It's just a piece of our circle. All right, very different from the measure. All right, arc measure, oops, let me slide this down. When we want the measure of that, we want a degree. When we want the length of an arc, we're measuring it like we would with a ruler. So is it, we're going to get inches or centimeters or something like that. So the actual length of an arc, as I just said, inches, feet, centimeters, it's a fraction of the circumference. So you're going to see this AL. You're also going to see a lowercase cursive l, also used to represent arc length. All right, either one is acceptable. So what we're going to do is we're going to take 2 pi r, which is our circumference, and multiply it times this fraction. So however many degrees, okay, whatever the measure of the arc is out of 360, the total, we're going to multiply that times the circumference, and we will get the arc length. So in our first example, it says if EB is 8 centimeters. So EB is a radius. So I'm going to go ahead and label that. That's 8 centimeters. Wants us to find the length of arc CD. not the measure of it, the length. All right, so, but in order to do that, I need to know the measure of it. So if we take a look, I see BD is a diameter. So I've got a semicircle. So 180 minus 43 is going to get me 137. So to get the arc length, I'm going to use the lowercase l. I'm going to take 137 out of 360, figure out what that fraction is, times 2 pi, and then the radius is 8. The 2 pi 8 gets multiplied to the top number of that fraction. All right, so on the calculator, you would just type in 137 times 2 times pi times 8, and then divide all that by 360. And our length is 19.13, if I round it properly. And our units are centimeters. This is a length. So if I actually took a ruler and measured what the length of that arc is, it would be 19.13 centimeters. Let's look at number 2. It says if VS equals 14 feet, well, V to S is a diameter, right? Is a diameter. Now remember, another formula that we could use, right, is really x over 360. If you don't want to use 2 pi r, you could do pi times diameter, because this is also a circumference formula. Or you could split the 14 and know that we got 7 feet and 7 feet on each side. It's up to you. All right, but it wants the length of, and missing my arc there. There should be an arc. So it wants the measure, the length of arc UT. All right, so to do that, I need to know how many degrees is that arc. So looking at my picture, we've got a diameter. One side is 90, so that means that these two angles on the left add up to be 90. So this one's going to be 42 degrees. That's my missing angle, which means my arc is 42 degrees. So I'm going to take 42 out of 360 times, and then pi times my diameter, which is the 14. And then just type that in. So we've got 42 times pi times 14 divided by 360. We get 5.13 feet. All right, now something I'm just leaving the L. I should be putting of arc UT. And up here in the first example, we should be of arc CD. So just cleaning that up, because on the worksheet, we want to label things properly. Okay, so that's your arc length. It's a fraction of the circumference. We also need to talk about congruent chords and what that does to the arcs. This first rule says if 2 chords are congruent, not if, sorry, it just says 2 chords are congruent if and only if, and it's going to be if their intercepted arcs are congruent. If their intercepted arcs are congruent. All right, so when I look at this, if I know that the measure of this chord AB equals the measure of this chord CD, then I know that these arcs are going to be congruent as well. So the measure of arc AB will be equal to the measure of arc CD. And then vice versa. If we're told that the arc measures are equal, then we know that the chords will be equal as well. All right, another rule for chords says that 2 chords will be congruent if and only if they are equidistant from the center. Equidistant from the center. So when I look at this picture, what I have to be told is from E to F, that distance, and then from E to G, that distance will be the same. That needs to be told to me. And if I know that those are equal distant, then I know that these chords are going to be the same length. All right, so the length of AB will be equal to CD. And then vice versa. If I know the chords are equal, then I know that they are equal distant. Now, the other thing I want you to add is that these distances from the center out are always going to be perpendicular. So the other thing you'll see on the picture are these little right angles. And that just tells you because the shortest distance to anything is always the perpendicular distance. Okay. And then last properties is about perpendicular diameters and chords. So if a diameter of a circle is perpendicular to a chord, all right, then the diameter, what it does is it bisects the chord and its arc. So in this picture, I see the diameter going through the center. I see that it's perpendicular. So what it does is it bisects the chord. So those two halves will be the same, but it also bisects the arc. So those two little arc pieces will be the same too. All right, now it looks like I'm missing, let's give this a letter right here. We'll call that F. So if segment AB is perpendicular to segment EH, all right, or CH, could be the radius or the diameter, then we know that from A to F is going to be equal, and then to F to B, and that also the measure of arc AH will be equal to the measure of arc HB. Okay, so let's look at a couple examples. So number one, if we know that segment LM is 41 minus 2x, all right, so 41 minus 2x, and N to P is 7x plus 5, find the value of x. Well, I noticed these two chords, and I'm sorry, not a chord, those two arcs are marked congruent. So that tells me that these two chords are going to be congruent as well. So 41 minus 2x is going to equal the 7x plus 5. All right, if I add 2x coming this way, I've got 41 equals 9x plus 5, and then subtract 5. I'm going to get 36 equals 9x. So x will be 4. In number 2, all right, what I'm noticing coming from the center is that the distance from the center is the same for both of these chords. All right, now I seem to be missing letters. So let me look real quick. So it looks like this will be C. So B, C, D. All right. And then let's see here. Find the measure of arc BAD. I'm going to guess A's out here then. All right, got our picture cleaned up. All right, so if I know the measure of arc BD is 9x minus 53, that's going to be up here. If the measure of arc CD is 2x plus 45, that's going to be there. But we want to find this measure. All right, so to get started, I know because these two chords are equidistant from the center that the chords are going to be congruent to each other. So I'm going to start by doing 9x minus 53 equals 2x plus 45. When I subtract 2x, got 7x minus 53 equals 45. Add 53. and then divide. That's going to be 1, 4. So I know x is 14. So how does that help me find the measure of this arc BAD? Well, notice that the two arcs that we were given and the one we're trying to find all add up to be 360, right? Let's make the complete circle. So I'm going to throw x into one of these two. It doesn't matter which one. So I'll throw it into the 2x. So I've got 2 times 14 plus 45. And that's going to get me 28 plus 45 is, let's see, 13, 73 degrees. So I know that that this arc here is 73 degrees and this one out here is 73 degrees. So if I add those up, right, or multiply by 2, I should say. So 73 times 2 is going to be 146. And then 360 minus that 146 gets me what I'm looking for. And that's going to be, let's see, 214. So the measure of arc BAD is 214 degrees. All right, so we had to solve for x first, substitute it back in to find our missing pieces, and then was able to go from there. All right, and the last example. All right, this one looks like it's labeled properly. So it says if the measure of segment PQ equals the measure of segment QR. So basically they're saying that these two chords, KJ and ML, are the same distance or equal distance from the center. Then I know then that those chords are congruent. The other thing that's being shown though is actually, if we connected them, which they are, this would be a diameter, all right? And so, and that diameter is perpendicular to both of these chords. So not only is it equal distance from the center, but it's bisecting these chords, which means these would all be the same. And it's going to do the same to the arcs. All right. JK is 3x plus 23, and LM is 9x minus 19. Those are the whole chords, and they are just going to be equal to each other. So we start with that so that we can solve for x. So I'll subtract 3x. Add the 19, and then x will end up being 7. Now, we want to find the measure of RM. R to M is just half of one of those chords. So if I substitute the 7 back into LM and get the whole thing, then I can divide it by 2. And I will have my answer. So we've got 63 minus 19. So 63 minus 19, which is 44. And half of that is 22. So RM equals 22. Okay. So those are a couple examples of some things you're going to do. We've got central angles, we've got their arcs, and we've got chords. All right. So come see me, but you should be ready to practice